All right. Hello, my name is Jason Freed, and I have been involved in Python for 13 years. And this is Keep Me Up with Python and what makes upgrades hard and what we can do about it. I work for the Python modernization team at Meta. I've been upgrading Python for over a decade professionally, from 2.7 all the way up to 3.8. And we went from 3.8 to 3.10, and we kind of skipped one. We went from 3.10 to 3.12, so we skipped one again. So some people at Meta successfully argued that if we only upgrade every other version, it would get easier. Well, that's not really true. But by the way, the longer you go between versions in an upgrade, the more people expect the versions not to change, and they subconsciously build in deprecated behaviors that don't upgrade. So the longer you take, the more those stack up. And so momentum is powerful and stagnation is a wasting death. But when it comes to upgrades, it never ends. Upgrading Python can seem like a Sisyphean effort. There's always a new version looming over the horizon. And once you complete one upgrade, the next one is ready to start all over again. So like the Greek myth of Sisyphus, who was cursed to perform the never-ending task of pushing that boulder up the hill, at Meta, I have also been cursed by some unknown gods to push this boulder up the upgrades hill. So know this, I know the pain of upgrades. I know them very well, and it's probably worse than most because of monorepos. In big tech companies, we love monorepos. I work in one daily. Just think of it as your normal Git repo for your project, but instead of just your code, it has everyone's code in it. And instead of a small team, there are thousands of people that are committing changes to it constantly. Every project at Meta lives in the monorepo. Every major PyPI project has a directory in the monorepo. So code reuse is really easy. But the problem with monorepos is code reuse is really easy. Dependency bloat is a real problem. Also, you have to ensure that there is a consistent version universe for all the dependencies in this universe, that they don't, and because everything is interconnected, and over time they approach even more connectedness. And because everything is interconnected, you can easily test everything. Unit tests become really powerful because you know right away if you broke anything at Meta, as long as that thing is covered by a unit test. I don't have to wait to build a wheel and send it over to somebody else and see if their tests are running. It just runs right there in the diff of where I'm changing it. So monorepos complicate and simplify the process. Now for something completely different. I hear sob stories all the time from internal project maintainers that they have ignored our posts about the looming version upgrades and wait until the week of, where we're about to flip the switch, and they show up and try to throw a wrench into the process and say, can we just stay on 3.10 forever? And yes, if you have the power to stop the progress of time itself, you can stop upgrades from happening. I actually tell them that yes, you can stay on 3.10 forever, but you have to manage the entire stack yourself, from the interpreter to the first party and third party dependencies that will want to move into the future themselves. And you cannot force everyone to stop progressing on your behalf. So even if you could do all these things, you shouldn't, because it will be hard for you. We will not revert changes to common libraries because you refuse to step into the modern world. You will have to end up forking everything and providing your own support. You can do it, but I would not recommend it. Look, I'm going to complain a lot about upgrades in this talk, but realize that upgrades are necessary. Every upgrade we've performed at Meta, for Python at least, has come with performance wins, both in CPU and memory efficiency. Being on a modern version of the language is awesome. All the new toys are there, and the 3,000 Python developers at Meta want those new features. But this talk is not about why we need new language versions, and this talk is about the pain of getting there. So let's talk about why upgrades are so hard. Sometimes the Python syntax changes between versions. Now a bunch of your code no longer even compiles. Then things that you were using from the standard lib have moved or went away entirely. Or the behavior of things that you were using are completely different now. And usage that was legal before now throws an exception at runtime. I'm looking at you, data classes in async.io. Sometimes there are changes in the Python C API causing breakages in compiled Python extensions that nobody has touched in 10 years or longer. And there's a lack of expertise to fix it. Nobody knows who wrote that stuff. They're not here anymore. So you have to develop that expertise. then almost most of the time, you have to upgrade when you have to upgrade your third-party dependencies to get support for those new Python versions. And that caused the introduction of changed APIs or subtle behavior changes. And third-party upgrades are already a hard problem, but combining them with Python version upgrades makes it nearly impossible. Now we have to do some things to make, now we can do some things to make upgrades easier, but this is not one of them. This code is real. It was seen in the wild. I can't confirm or deny that it was seen at Meta. In case you are unfamiliar with this code, it's how you silence warnings so that no one will ever see them. In this case, it's ignoring the warning that distutils is deprecated and that the logging.warn method is deprecated. Don't do this. This is the Python equivalent of shoving your fingers in your ears and yelling, I can't hear you. You're just ignoring reality. It doesn't fix the underlying problems. And I repeat, do not ignore the warnings. Fix them now, not later. The future is going to hate you when it finds these things because those warnings will turn into exceptions. And what could have been planned for as something we could fix is now a reactionary emergency. So don't hate on the warnings, but love the warnings. Embrace the warnings. They tell us what needs to be fixed. If you don't see any warnings from your Python code or someone else's, or you've never seen a warning message before, then your environment is most likely suppressing them. So I personally live with this environment. It's the Python warnings environment variable, and at all times I set it to once. So that means that anytime a warning will happen, you will see at least once. And it won't be flooded with them. But I want those warning messages to bother me. I want them to motivate me to fix them sooner rather than later, because I would like to know about failures before I perform an upgrade. I want no surprises during the upgrade. So let's get started with the upgrade. We talk about code mods. In the old days, back in the old days, I would take a month and I would by hand go through every file that threw some kind of error when we tried to run it in Python 2, and I would hand fix it for Python 3 or 3.4, 3.7, 3.5, and I would just use Vim. Well, when you get to a certain size, there's not enough people or hours in the day to fix code by hand. You need to have the power of robots. So we have things like regular expressions. This is kind of an old school way. You use a regular expression substitution, maybe using Perl, no less, and you mutate old patterns into new patterns. But that could easily introduce syntax errors. And it might also apply to code that you didn't really want to apply to. So it is and was a crude tool to inflict on Python syntax unsupervised, and should be reserved for all but the simplest changes. But there are better, more powerful alternatives. Like we have libcst, the open source library. You can build custom code mods in a way that respects syntax, and in some cases are type aware. This is a powerful tool, but writing code mods does take time, and they need to be well tested. So if you only have a handful of things you need to change, it might be faster just to change them by hand than trying to write a code mod to do it. So it could take several days to write a working code mod. So to do something like, so make sure it's not something you can do quicker just by fiddling with it. So keep that trade-off in mind. I reserve these for things that are probably happening more than 15 times in the code base and are likely to keep happening, like deprecated assert names in unit test calls. Those used to just seem to crop up all the time. So it's good to have a code mod to get rid of them on a regular basis. Also, there are some pre-made tools like PyUpgrade. This is a project we found on PyPI. It's a tool where you can use it to perform automatic syntax upgrades. As the language evolves, certain syntaxes need to be changed, and this thing will do it for you. Their documentation says you can use it in a commit hook. So they think it's very safe. We do it via code mod so that we can actually look at the diffs. I think at the commit hook level is a little scarier for us. So it's nice to be able to have at least a human looked at it before it gets committed to the repo. But it's the future now. Has somebody not invented a better way to do code mods? Well, we do live in the age of generative AI. Maybe one of those fancy chatbots can help us. But you need to write well-constructed prompts, like telling the chatbot that they're good at their job. Hey, chatbot, you're a Python expert and are well-versed in the techniques of upgrading Python code between versions. So I've been told that it does help that if you encourage your chatbot, you tell them they're an expert, they seem to do better. But you need to be on the lookout for hallucinations. Chatbots are very good at generating convincing looking things like code. And sometimes it's complete nonsense of spontaneously created APIs that only look like they are correct. So make sure the code you're changing is well tested and covered by things like type checkers and linters. But we do not yet live in this utopia where an AI bot can do all of your work and yet you're still employed for some reason. So keep a sharp eye out if you go down this route. Your efforts might be more amusing than helpful. So what else we can do to make upgrades not so hard is, we can talk about code hygiene. You can write code that is harder to upgrade. So let's go down some simple rules to avoid that. Do not touch other people's private variables or functions. You can tell they're private because they start with an underscore. That underscore tells you that it doesn't belong to you. Do not touch them. I would go even as far to say that if you're importing or referencing an underscored thing from some other module, that's code smell, even if you own both modules. These things are not public. You have no guarantee that they will stay the same in the future. Expect them to change without notice in surprising ways. Next, we have implementation details are not guaranteed. They change, and they change often. I've come across code that used the DIS or DIS module to inspect some code to ensure it was not violating some rules the project had come up with and they wanted to enforce. The problem is the DIS module, the DIS module, if you don't know, it shows you opcodes your Python syntax turns into that is being actually run by the runtime. This is the closest thing we get to Python assembly code, as you will, and it's executed by the in a loop by the runtime. This is what we cache in PYC files. Well, the output of the DIS is unique to the Python version you're using, especially in 3.12 and 3.13, where the optimizing, specializing, opcode execution loop, or whatever it's called, thing changes it. It can change the opcodes between runs of your function in the name of performance wins. So this thing is inherently tied to implementation details that you can't rely on. So every version you'll have to fix your code. So unless an implementation is guaranteed, kind of like dict key insertion ordering in Python 3.7, don't rely on it. Like in Python 3.6, it was an implementation detail at that point. And we were all told, don't rely on it. We might get rid of it in 3.7. We lucked out. In 3.7, it was made a feature of the language. But relaying on that sooner is a risk that time will make you wrong. So that brings us to rule 3. As things mature, they change and become more stable. This could be brand new third-party packages. It could be async IO back when it was called Tulip. Be careful about being an early adopter. Projects usually figure out their APIs over time and rework them in incompatible ways, requiring refactors of all the existing usage. Maybe this is data classes when they added the new helpful prohibition against mutable defaults. Or it's async IO, which just changed the behavior of the wait function to only accept tasks. Or concepts of default events loop are just gonna go away soon. If you walk the bleeding edge, you will get cut and you will bleed. Be prepared that there will be lots of churn. Did Meta adopt async IO too early? Yes, most definitely. I was there, I committed it, but we didn't have a lot of alternatives at the time. But we should expect that there will be change and we're gonna have to deal with it. So like all good rules, there are exceptions. And sometimes, try as you may, you will have to reach into the guts of something and use its private functions in the standard lib or some third-party stuff, or you'll rely on some implementation detail. In those cases, you must use a comment. Tell us in the future why you made the risky decision you did. Tell us what that thing does, because it may not exist in the future. We might be able to easily find what it was. And what are you using it for? And include a message begging for the forgiveness from the future developers that will come behind you and fix this code. For the new Python version where your assumptions are no longer true. Be verbose, and better yet, even add a unit test that will confirm the implementation that you're expecting still works the way you expect. So that when I, as a person upgrading Python, I can know before I commit your code or push your code into production, it's gonna fail. And generally, you need to expect that Python versions are going to change. Nothing remains static for long. It might change next week, or even tomorrow, or maybe the next 10 minutes. Think about it when you design your system that uses 250 PyPI projects with hard version interdependencies. where the slightest behavior change will ruin what you're trying to accomplish. So provide documentation for the future, because it might not be you maintaining this code in that future. It might just be me still pushing that boulder up the hill. Now, while we are on the subject of third party, let's talk about the pain involved in third party. This comes in many different shapes and sizes, GitHub, PyPI, closed source or open source. But for this talk, we're mostly talking about things out of PyPI. Most of the time, when you update a third-party package to support a new Python version, it's not a drop-in replacement. People like stable APIs, so they don't upgrade their third-party packages very often, and unless they really have to, like when needing to support new Python versions. This many times requires a giant leap in version numbers. So not only are you having to juggle a new Python version breaking your things already, you have to contend with the APIs you were using in that popular third-party package no longer existing or producing completely different results than it did before. Now, there are solutions for this. There is the long-term support model, or LTS, as it's often abbreviated, and that could be helpful if more than a handful of projects decided to use it. The idea here is you pick a version of your module, support it for a longer time, meaning only bug fixes and no new features, but most importantly, no API or behavior changes. This means that you also release new builds for when new versions of Python become available. Now, this doesn't mean you're stuck forever supporting this old version. You can just say guarantee it for like maybe the next 2 Python versions, which is generally enough not to catch people completely unsurprised. That brings us to pre-generated Python sources are not helpful. But wait, what is Python, you might ask? Python converts Python code into C code, so that you can get speed or you can interopt with C or C++ code. I have lost account of the number of times that a third-party project only required me to regenerate their Python sources for them to work with a new Python version. It's so common. At Meta, we frown on using the pre-generated Python sources, and we generate them as part of the build. So every time I do a build, it's going to make sure they're up to date. It only takes me updating the Python package itself to a newer version to get a huge swath of third-party code functioning for a new Python version. In my honest opinion, you should stop shipping those pre-generated C++ sources that come out of Python. It doesn't take your users that much longer to download Python also, and it's not really buying us a lot of time other than making your source distributions not build in the future against future Pythons. Or at the very least, make it easy for me to regenerate your sources. So if you have released a package or source distribution that does not include your Python sources, your Python like pre-sources like PYXs and PXDs, do so, so that I can easily regenerate these things. Now, there's also a problem with no source packages. I hate these so much. I'm not, like diminishing your income mechanism, but like proprietary sources are hard to deal with. But if you're providing a compiled dynamic library written in C or C++, and you're also providing a Python interface to said library, in my opinion, you should make the Python wrapper not closed source as well. Document your C APIs, keep them closed source, but use something like Python to generate wrappers for your Python code and provide that code so that those wrappers because those wrappers don't really have any logic anyway, and we could regenerate them so that we could get more, so companies that provide these things take really long time to get us new versions. Or like I'm from a couple steps removed from whoever originated that code or who purchased that code, and I'm trying to update you without a lot of help or support from you guys. I don't have the time to go and find out what company it is and get a new version from them. So it would be nice if we could just regenerate and we could support newer versions of Python, because the C stuff isn't changing. It's just the Python wrapper stuff that's changing. I can't hold up a giant upgrade waiting for you. So it would be great if that's not possible, that's like, you could never convince your bosses to do something like that, maybe at least use the stable C API so that hopefully we can get more than a single Python version out of the product you give us. It'd just be faster for us. And like I said before, your project code is just a directory in my repo. It builds by our build system, Buck 2. Interacting with it is as easy as interacting with first-party code, so there's really no different. So I will backport changes from newer versions of your package if it means I can get support for new Python versions without having to also accept API, or behavior changes. Does it mean more tech debt? Sure. Does it hurt me in the future? It might. Will I still do it from time to time? Yes, I will. Because the Python upgrade is already, the Python upgrade is more important than driving thousands of third-party upgrade campaigns across thousands of different internal projects. It's not ideal, but software engineering is about trade-offs. We can't do everything at once. Let's do the upgrade now, and we can worry about moving to new third-party versions later. So let's bring this back home. Upgrades suck, and they constantly happen. They never end. And don't get me wrong, I have a love-hate relationship with upgrades, but I still champion them. They are necessary. Using automation to make the process easier and farm out your work to others, if possible, and just don't make it harder on yourself by assuming that they don't happen at all. And document the process so the next time you do an upgrade, you won't forget something very important. So thank you for coming to my talk today. Thank you for Meta for paying my way here and sponsoring the conference and supporting the Python language that we all love. I have a little bit of time, like 10 minutes, for anybody who wants to ask questions.
Hey, thanks. It's a great talk. So you mentioned a really bad case of someone using the dist module to basically build code health tools, which is kind of ironic. What's your opinion of using AST for that, the AST module, and working at that level to try to do verification and things? That seems to change less often. I mean, it changed a little in 3.10 with the constants, but...
That would probably be more appropriate. I guess I'm not exactly sure why they chose that. They didn't have a lot of comments when I went to go fix it. But luckily, they were still there, and they were very responsive. They were able to fix it within an hour. Even though I thought it was doom, I thought, oh no, we're not going to be able to fix this. And I complained a lot to my team. I sent them a task, and they fixed it in an hour, and I was very impressed. I would not have done that. I would not have designed that way. But as long as they're willing to be very responsive in updates, it'll keep working.
I've got a gaggle of code bases, probably numbering in the dozens, if not hundreds, that are principally written in the 3.5 to 3.6, maybe as new as 3.7 era. What would be your recommended strategy for getting up to something more current beyond incremental version changes, or go up to current and fall back until it works?
The most we've ever done is skipping one version. I don't know if I think that's like, is waiting for a long time just makes the problem worse. And I don't know if it's easier for you, if you're in 3.5, to jump to 3.7 or to go straight to 3.8. I have a feeling that you don't want to jump too far because there's so much is going to be different in that future that the amount of changes that you have to do now is so great. Is that what you're looking for?
Kind of, as well as other strategies. It seems like skipping every other version and then maybe.
Yeah, I think we've had a lot of like personal like talks in our team. It's like that skipping every other version is just, it's too slow. And if we can like, if the versions are coming out fast and we can move very quickly, then it's not so bad. But it's just the momentum of bad code. Well, not it's bad, but code that's not future compatible starts to compound. And the quicker you can get people to like accept a cadence that's happening very often, the less they're likely to make that code that is not upgradable.
And then one more is, how do you pitch the value of version upgrades to executives?
So this is the thing where when you talk to executives, you use terms like existential risk. That might be a little hyperbolic, but where you say it's like, look, what's the case of us not moving? And you can say eventually we'll fall out of support. We won't get any support from upstream. Eventually that turns into only security updates, and eventually it turns to no updates, and then we're supporting it all our own. If security things happen to show up, we won't be able to, we'll have to fix them ourselves. We may not have that expertise. The other is if we wait long enough, even the third-party stuff is going to start breaking. The OSs that they run on is going to be crumbling. You're going to get to a state where there is no way to run what you're doing. You have to like spin up an OS from 10 years ago and hope you don't get hacked. and then you can run your stuff on it. So it is a risk. It's something that we have to measure. You have to guard against, like any other risk for business.
Hi, thank you very much for the interesting talk. What is your? I'm pretty sure the 3D threading upgrade will be very difficult. What are your emotions on them, and what kind of problems do you foresee for those upgrades?
I'm excited about the concept. They didn't tell me to say that. I've been really excited about that. We've played with it. We have it internally. You can play with it. So it's because we have 313 experimental. I like it. It's nice. I think the biggest problem is over the years, I've written code like this where you just kind of expected the GIL to always be there. So you would use it where you're like, okay, I need to make sure no other Python code is running while this is happening. Now there's things, I think there's like critical section for Python that you can do this still, but there's C++ or C code living in our repo somewhere where it's like, oh, the GIL will be held, so I don't have to worry about two things coming through this path at the same time. Now that's easy enough. You just tell the person, well, add your own mutex. That's probably the biggest. It's just basically a lot of mutexes that need to get added.
Thank you.
I have a question. Do you have any benchmarking internally to test reliability because you have a lot of Python in prod?
Yeah. So the question was, are we doing benchmarking between like upgrades, so like an A/B test of like where we saw? We do. Like various products have things like that, especially Instagram. They can tell you very quickly if there's regressions. And usually it results just like either we're not like doing the same optimizations we were in 310, or it's like because we're doing things like PGO, and we're doing sampling PGO where you take like the running work of your entire fleet of web servers, and you like, well, what are you actually doing in Python? And we're going to optimize the build of the libPython based on that work. That's hard to do when you're rolling out a brand new version and you don't have any servers running around running that version yet. Does that answer your question?
What are PGO?
It's profile guided optimizations. It's something what you do during the compile to make things improve cache locality and like things that I'm not an expert in these things, but it gets you about a 20 to 30% win on performance for CPU.
Okay, thanks. I also have another question. Do you have any preventive measurements? You already regret that you skipped the versions, but do you fix the deprecation warnings?
Yes, we do. Like I might be the only one who actually sees them because I don't know a lot of people that run with the Python warnings once, and we hide them by default. So because we don't want them to show up in production. But it does. It's like I think that came from mostly the 2.7 times when it was like we were in 2.7 for more than a decade, and people just kind of grew that Python would never update. So all the deprecation warnings, you're like, oh, we're safe to just ignore them because that build date will never show up, and that was hard to break people of. And you're like, no, when you see a warning, don't ignore it because it's gonna get here quicker than later.
No, do you force people to upgrade?
Forcing people is kind of a hard thing to do. I'm not in their management chain. I can't force anybody to do anything. But what's worked with us recently is just insinuating that all the work that we're doing for them today in managing and making sure things are performant, they have to do. And not only that, they have to basically make sure everybody in the company is not going to break them because everything's interconnected. It's a monorepo. Things get more interconnected as time goes on. They can't afford to not upgrade because there's too much stuff that's not in their control. So that's usually how we kind of enforce this. Not so much. It's just the threat it's just natural consequences are going to happen to make it very difficult for them to do their job.
Okay, thanks for the great talk. One problem that we ran into with a recent Python upgrade was when you have third-party libraries that haven't upgraded to the Python version that you want to go to, but people need to use. So something like we did was just building custom wheels that we then have to maintain, and it's like a whole mess later on. I'm wondering if you have better solutions to that specific problem.
I don't. I know we internally ran a version of Python that was we'd hacked on it because it was like at the time we needed something that was only available in the trunk version. So we pulled out trunk and we hacked on it for a couple months, and we ran that for a long time. And it was hard to jump from that to like the 308 version. I had to pay that cost. It didn't actually take as long as I thought it would. It was like a couple of weeks work. That might seem like a lot if you're on a small team, but I would say you have to make trade-offs. We ran a version of NumPy that was really old. Like if we had gone to the maintainers of NumPy and says, "Oh, I'm running this version on 312," they'd have looked at you funny. Or well, I guess at the time it was 310. They would have like, "What? That's not possible." We're like, "Well, it is if I patch NumPy to work for 312." You do what you have to do. And if that means that you have to upgrade later, I would say you want to try to separate your third-party upgrades from your Python upgrades. So either pick one. So if you can upgrade to a new version of that third-party thing in your current version of Python, do so, and then later upgrade your Python. For us, the Python upgrade is the most important thing, and that's usually how we discover that those third-party packages have to be updated as well. So we usually do the upgrade first, and then we get somebody to, we sometimes do both, but like we upgrade them first and then do the swap, or do the swap and then later be like, "Hey, you guys should update this thing."
Okay, thank you.
It would be nice if people who are creating CST transforms, libCST transforms, could share them with the world. Any thoughts on that?
I think so. I've written exactly 0 CST transforms. I've used the ones that a lot of my coworkers have written, and they write a lot. So it's not just me making all the code mods. I use their code mods, and they use their own. So there is examples, because when I went to write or fix one, I was on the normal internet looking at examples for libCST. It's like libcst.codemod. And so it's a module that comes in that package, and it has examples of how to do these things.
Okay.
What was that? Oh, and Fix It. Well, Fix It's on top of libcst? Okay, so there's another thing called Fix It. I thought they were the same. And it basically makes it easier to use libcst to drive code mods.
Okay.
They're all open source. Okay, so all the ones we do are already a part of the open source. This is most of the major ones we're using. So it's there. You just have to find it.
Hey, yeah, great talk. So one of the issues I found with running inside the monorepo is that you don't want to upgrade your package after the new Python version has rolled out. So you need to maintain like 310 and 312 compatibility at the same time. And that's like a really big reason to turn off warnings. So have you found any way around that?
So wait, so turn off what?
Turn off warnings because you're going to get spammed with warnings either way.
Oh, so in that example, the code, there was no comments there. There were no tasks. There was no plan to actually fix those things. It was just like, I'll ignore them forever. So yes, if you do have a plan to get rid of the warnings, like we can't, like there, when we were doing 2.7 to 3.5 or 3.4 at the time, that was a long time ago, but there were cases where you couldn't fix it today and support both 2.7 and 3.4. So we would ignore them. And it was like there was a big comment and a task attached. It was like, when we do make the switch, just get rid of this set of code because we're not technically using it anymore.
Oh, yeah, sorry, what I was trying to ask was, have you ever come up with like a more principled idea to sort of stage warning deprecations and say, hey, when we actually flip the flag, these won't be warnings anymore, but for now, please don't tell us about them?
Not from like there is a project going on right now where we're going to start collecting warnings that happen during unit tests and like putting them as separate signals on your diffs. So be like, oh, there were warnings generated. Maybe you should fix them.
Yeah.
It's a brand new project, probably for next half. So I don't exactly know a lot of the details on it, but we're going to try to do something like that. Basically, keep track of warnings so people know that they're happening because a lot of people don't see the warnings.
Okay, great.